Hello everyone, and welcome to another installment of Math Today. So we've talked about the beginning of this chapter, working on linear functions in a few different ways. Today we're going to talk about something special that we call direct variation. So variation is how things change together. A direct variation is a very special situation that we're going to see here. And it's special because your graph always goes through the origin. It also has a really easy equation, really neat, really easy to remember. So we practice some rates of change. We also call those slope. Now we're going to work on writing and graphing these equations in a few different ways. We'll solve some problems as we see coming up. So some vocab to think about. The main thing is this direct variation phrase. Fancy wording just means how does a variable change? Well, it's going to change in a very specific way that we're going to see. But what this really means is that our graph goes through, and you should have this down in your notes for this section at some point, goes through the origin. Now, if you're not familiar, if you don't remember what the origin means, origin just means through the middle of the graph. So here's your graph. The origin is this point right in the middle. That's the origin. So every graph that has direct variation is going to go through that point. So it makes it a lot easier to graph. We'll look at a constant that goes with these of variation. We'll talk about some proportionality as well. So to start with 1a, we need to copy down this graph and we'll name a couple things in here. So don't worry about the instructions, but do draw the picture and we're going to label a couple things here. So first, we notice our line is going through the origin, through this point right here, 0, 0. And we've got another point outlying here, also on the line. And they tell us our line is the equation y equals 2x. So notice there's nothing added here. There's no 2x plus 1, 2x minus 6. It's just 2x. So any equation that is direct variation will look like this. Some number times x, and that's it. So it's going through the origin, we have that graph. So first thing here in our instructions, it asks us to name this constant of variation thing. What does this mean? Constant of variation. Well, we know constant means just some number, right? So the constant of variation, where in our equation do we see just some number? Well, it's this number attached to x. In this case, the number 2. That is our constant of variation. We can label that COV. That tells you how the graph should be graphed, what it should look like, how steep the slope is. So the COV for this problem is 2. Now they ask us to find the slope of the line using these 2 points, and we practiced that last time using our slope formula. So we can do that. We found the constant. Now we'll find the slope to double check. So first, this is our given slope formula like we practiced. We'll find the change in the y's and the change in the x's. So if we say the origin is our x1, y1, and this point over here is our x2, y2, that gives us these two. We'll start with here, the difference in the y's. Let's circle a couple things. The difference in our y's, these are both of our y's. We're going to start with this one because this is our y2. So we'll do 2 minus 0 like we see there. Then we go to the difference in our x's. And we said we're starting with this one as our x2, so we'll do 1 minus 0. That's how we get this on the bottom. So using those steps, we can very quickly find their slope. We know 2 minus 0 is just 2. And 1 minus 0 is just 1. So what is our slope? Our slope should be 2. So we found the constant, it was 2. The slope is also 2. And we proved it by finding it between those 2 points. And that is all we're asked for that problem. So the COV is 2. The slope is also 2. Same thing for these direct variation problems. This number will be the same. Okay, so with a similar example, we should not have any struggles figuring that out. So 1b asks us to first name that COV. Name this thing. Well, what number is attached to x? Very clearly we see a -4. So a 4 is attached to x, but there's also this negative sign here. So we must include both the negative and the number. So in this case, our COV is a -4, which is fine. We can just say that. There's no operations we have to do to get there. Just look at it. And now it says check and find the slope of the line given these points. So we'll use our slope formula and plug in. So if we say the origin is our x1, y1, and the point 1, -4 is our second point, we'll find the difference in our x's. These are our x's. They always come first in your ordered pair. And here's the difference in our y's. In red here. We'll do -4 take away 0. So very quickly we can solve this now. -4, you don't change it, you get a -4. 1, you don't change it, you get 1. -4, anything over itself, just itself. So the slope for this problem should be also a -4. That is our slope. We can use the letter M. So we've double checked with both of those. Slope is -4. Our COV is also -4. So we've answered all of the questions using that slope and that formula. So we're good. We're working through this. We understand these concepts. Very quick, not too difficult. Okay. So 1C, same process, but this time they're giving us some multiple choice options. So what do we know? We know, and you should draw a picture for this, don't worry about the words. We know our COV is the number attached to x. Our constant has to be 4. So our COV is 4. That allows us to eliminate C because this is a negative, and D because this is a fraction. So A or B is going to be correct. Now one has a slope of -4, the other has a slope of +4. And what do we say about lines that go up to the right? They're either positive, negative, 0, or undefined. So lines that go up to the right, we talked about this yesterday, and double check in your notebook. But we said lines that go up to the right, like in this fashion, are always positive slopes. And you should have that from last section as well. So without even subtracting these points, we already know this has to be a positive slope. But if we want to quickly double check, we can label this our x2, y2. This one's our 2's. This one will be my x1 and my y1. And then I can quickly subtract. So y2 minus y1, 4 minus 0, over 1 minus 0. So what is my slope? Just to confirm, 4 over 1, which is just a +4. So we know that A is wrong because this is negative. That's not okay. So B is our correct answer on 1C. Very easy, not too bad at all. Okay, so 1D, more options. So find that COV. Well, it's just the number attached to x, right? So look at your equation. There it is with the red box. Our COV has to be -3. So draw yourself a line on your graph that goes through the origin, through this point, and draw that up to the left. Now notice, our COV is a -3. And we've seen the pattern now, so we know that our COV is -3, and our M, our slope, is also going to be a -3. when we subtract those points. And you could double check that here. You would get a negative 3 over 1, which is just negative 3, so that's fine. So m is negative 3, and our COV, our constant of variation, is also negative 3. So we have those things. Now what do we know? Well, we know 1/3 is wrong. Constant of variation can't be 3. That's also wrong. Can't be 0. We know that's out. So D is going to be our correct answer. Now notice looking at the line, it goes up to the left. What did we say about lines that go up to the left yesterday? We said they have a negative slope. So lines with a negative slope go up to the left. That makes sense in this problem, so we double check that. D is our correct answer for this. Okay, so 2A. Now we're looking at a little bit different of a problem. This time we want to work on, given the equation, draw a picture. We want to graph it. And we can graph these no biggie because we're already given a point that we know it goes through. Since this is a what we call direct variation, meaning it's going to go through the origin, there's no number here. You can imagine it's just plus 0. There's no number here. So it's going to go through the origin. So that's already giving us the point 0, 0 that we know our line is going to go through. So that makes us already have a starting point to graph. So we know the slope is given by the number attached to x. So for these direct variation problems, when there's no number added, this is our slope, right? And that's not new. The slope is always attached to x. That's our m, our slope. So we have a slope of negative 3/2, and it's going to go through the point 0, 0. Right there, we already have enough information to graph it. Start here, drop down 3, and go over 2. We'll rise negative 3, run a positive 2. That'll give us a second point, and then we just draw that line. Very easy. So there we go. Graph of the origin. Simple. That's going to be on every problem. We've got that right in the middle of our graph. No biggie. Now from that point, we'll move down 3 because of the negative 3. So let's break down our slope. We have negative 3 and a positive 2. The negative 3 is the rise part. That's our vertical part going up and down. So rise in negative 3 means go down 3 like we see here. That's a negative 3. Then it says to run 2. So run is our horizontal, left and right. So from here we run positive 2, 2 to the right, 1, 2. That's where we get the slope, negative 3/2, negative 3 over 2. So now we have two lines, now we have, or 2 points, excuse me. Now all we have to do is connect those with a line and just continue it on, and that'll give us that graph. And there we have it. So notice the graph goes through the middle, that's the origin. Every graph we do will go through the middle. If yours does not, you made some kind of a mistake, so you can always use this as a reference to make sure you're doing the right thing. Always, always, always with direct variations should go through the origin. So there you go. 2b. So looking at these options, 1 is right, 3 are wrong. We want to graph y equals 2x. So first let's check. Do all of them go through the origin? And looking at A, B, C, and D, they all do go through the origin. So that doesn't help us. 2 we know is our slope. And 2 is a positive number, right? Not a negative number. So we have a positive slope. So using the rule we talked about last time, we know positive slopes go up to the right. So it should be leaning up to the right in some way. So in other words, of these choices, if we have a graph that goes up to the left, we know it has a negative slope, and we know that that is not right. So looking at these, I see D goes up to the left. That's a negative slope, so that's not right. A also goes up to the left. Negative slope, not right. So B and C both have positive slopes. Okay, so one of these is right. Which one has a slope of 2 though? So 2 over 1 is the amount that we rise, our change in y, over the amount that we run, that is our change in x. So from this point in the origin, we should rise 2 and go over 1. So we should go up 2 and 1 over. So from here, if I look at C, if I rise 2, go over 1, that gets me here. That's not on this line. So let's hold off on C. If I go back to B, start at the origin. If I rise 2, run 1, bam, I land right back on that line. I graph it. B is a solution to this system, a solution to this direct variation equation. So we know B is right. C is out. So we're done with that. We graphed it, pretty simple. Check the origin, find the slope, plot that line, and you're good to go. So double check, and we see our red circle signifies there B is correct. On graphing these, you can do it with just a couple steps. So please have that picture as we move on to the next example. Okay, so there are direct variation graphs. We talked a little bit about these. So we know that there's a couple things we can see here. So with the direct variation equation, they're always in the form y equals kx, which just means it's y equals some number times x. So that could be y equals 2x. That could be y equals 1/2 x. That could be y equals negative 3x. All of these are cases where it's some number multiplied by x. So k is just whatever this number is in front of the x. So direct variation, anything that looks like this, and it always passes through the origin. We've established that. So the slope is positive if k is a positive number. Slope is negative if k is a negative number. We know that. If the number in front of x is negative, it's going to go up to the left. If the number in front of x is positive, it's going to go up to the right. So we've talked about those things, so that shouldn't be too bad. So we can solve a couple algebra problems using this property to help us. So suppose y varies directly as x. Suppose that it's a direct variation. That's all that means. We're going to say y is 9 and x is a negative 3. That's 1 point. That goes together. They say write an equation that relates x and y. So how do these things possibly relate? Well, we know it's a direct variation equation, which we just said is always of the form y equals some number k times x. So using this, we can plug in what we know and write that equation. So this is our blank equation to start. They said y is 9 when x is a negative 3. So where there is a y, I'll write a 9. Where there is an x, I'll write a negative 3. Bring those straight down. And now notice there's only one thing we don't know here, that's k. The y and the x, we know what they are, we plug them in, we're good to go. The k, we have to find. So now we're just with, can you solve a one-step equation like we practiced? So divide both sides by negative 3, what do you get? Well, k equals a negative 3. Eliminate here, 9 over 3 is 3, keep the negative, there you go. So k is a negative 3, but we're not done because the question asked us to write a direct variation equation. So we need to know what is y equals some number times x. We need to know what that some number is. Well, we just said that k is a negative 3. So in this blank, put in a negative 3, and this is our equation. Y equals negative 3x. So on our next slide, that's what we're going to see as our solution. The direct variation equation, simple, y equals negative 3x. Okay, so with another example, want to use the direct variation equation, find x when y is 15. So we just said, this is a two-stepper from the one before. We said y equals negative 3x. and find x when y is 15. So in other words, replace the y with 15. So 15 equals negative 3 times some number x. What does this some number have to be? Well, if you can't see it, you can quickly divide both sides by negative 3. This goes away, that's just 1. 15 divided by negative 3 means x would equal a negative 5. And that is all, just a very quick step. To solve that, if y is 15, x has to be a negative 5. That's the only number that would work. And we see that solution. One step, plug in, and there you see it. X has to be a negative 5 if y is 15. So if you can do these problems, you should be okay. As we move into some practice, show your skills, see if you can work through these, follow the steps, and be on task.